Plotting a raster file in Python is very easy if you know the basics of Python. So in this video we will discuss how we can do this with a simple lines as explained further in this video. Also, if you want to learn about how we can plot a shapefile and various parameters in it, you can check out the previous videos in the description as well as the I-bars. So getting back into our video, in this video we will see how we can plot this kind of files and what is the code which we will use to do it. If you see this code here, this is the code which we have previously used for making our shapefile. So we'll be using the similar concept. We'll just change the things, like instead of using shapefile, we'll be using a raster with additional 1-2 lines. That is the major difference in between the code and shapefile to that of raster file. If you have not yet seen the previous 3 videos where I have talked about this code, you can watch the video here in the I-bar, or you can also find it in the description. So coming back to the topic, so in order to apply it for a TIFF file, firstly we need to know how we'll be able to get a DEM or a raster file. So I'll be downloading this raster file from src.read, which is available around the world for free. This is the website which I have used. As you can see here, the data is available for all around the world with around 5x5 degree cells or grid, and also as 30x30, and you can download it in 2 formats. So in this case I have downloaded data as 30x30 cells which belong to India for a certain river basin. So once you download it, those are TIFF files, and these TIFF files you can directly use it in GIS or even in Python to apply for the purposes we are using it for. So coming back to the code which we'll be using is, as you can see here, this is the code which we'll be using for our purposes now. So most of the plugins which we have already used in our previous video, we are using the same one, so we will not go through in detail. The thing we changed here is, here the first thing we are doing here is importing a raster. So if you see in our shapefile, we have imported the shapefile like this, and we have read our shapefile using these 2 lines. In our case now, we will be importing our raster using Rasterio. So this is the plugin which we'll be using for importing our raster file. So as you can see, I'm using rasterio.open, and I've given the whole path where the file is, and then I'm reading the file. So using these 2 lines, we are opening the raster file at the certain location and reading all the information in it. So after that, again we are formatting the axis as we have discussed in our earlier video, and we are developing a figure subplot here with figure axis subplots as discussed in the earlier video again. So most of the lines which I'll be dealing with I have already discussed in the earlier videos, so you can have a look there. In our videos now, I'll be explaining more only the lines which are unique to this. So first line out of those lines are these 2. We have already discussed about zpal earlier. So in our case, we are having different values because here we are dealing with digital elevation model, which is 90-meter resolution as we seen downloading. So the zpal here indicates the elevation data which we have. I viewed this data in GIS. You can also view it here before you define the values of your limits. I viewed it in GIS, and these are the limits which I have chosen for a good representation of our DEM map. And then I've given various colors. Again, based upon seeing how good the colors look, I've chosen these colors uniquely by trial and error method, you can say. You can use it various different colors for representing the DEM. I've chosen this because this looked apt for my work. So the next thing, again the C map, we are just developing our color map here and saying use the zpal as well as RGB, whatever we have created here. And the next line here, this is one of the unique line which we are going to use here while plotting our TIFF file is, as you can see here, a new command called imshow is being used here. The imshow function is generally used for whenever we are trying to plot a raster file, we use imshow with respect to the axis. As you can see here, I'm writing axis.imshow, and then I'm asking it to show my raster. How do I want to show it? With our CMap, and the extent of the raster again being, I want it to have the correct coordinate system, because I'll be assigning the base map behind in the background after this line. So I'm giving it extent as well as interpolation none. It is quite similar to what we have in our shapefile plot. As you see here, we are plotting it, but here we did not talk about our CRS. Coming to the base map, we have talked about it. So it is very important for us to have this extent correctly, because as you see in our next line, we are using the same line, asking it to go to the axis, plot the CRS, and have the perceptron thing to plot our background map. So in this line, we are telling it how to plot, and this line where we are saying ctxt is giving our base map. And if you see the next line, it is the same line as this, but I'm saving the information as IM. The reason I'm saving it is because I'll be using this IM to be able to plot in our next lines. So coming to the next 3 lines here, I'm again reading my shapefile, and then I'm asking it to plot only the boundary. So if you have seen our previous videos of plotting our shapefile, in the second video we have created the boundary plot where it shows only the boundary, it does not show the fill. It's almost like a transparent image of whatever the shapefile you have, showing only the boundaries. So I'm plotting the boundary here because I want to have the clean outline of our TIFF file what we are plotting. So once we have done these things, the next thing again which we have already known is about how we install our north arrow based upon its location, its north size, the length of the arrow, etc. And then also the scale bar. Here I've changed it to 1:1. So here 1 unit is equal to 1 kilometer. That's how I've defined, and I've told it where it should plot it. So once we have done that thing, again we come back to our axis parameters again, which we have discussed quite extensively in our previous videos, and then we are just asking it to plot it and label the plots as X label, Y label. I've changed the title here from flood maps or Catalonia in the previous one to that of digital elevation map. And next, one important point which I need to mention here is this one. So when we were defining our C-bar in our previous video, if you see here, if we go there, we are saying C-bar is equal to plot color bar of scalar mappable, where we have all the information of our color map, etc. So here we are linking up with our raster. So what I want to tell that to the code is go to the information which we have here, and in this itself we already have a CMap integrated. So it goes to the IM, sees the raster, plots the raster with the respective color map. And again the aspect ratio, everything is quite default. I have not changed much. But the next thing which I've changed here is these 2 parameters again. So the next thing, 2 lines which are important is the color bar ticks, which we have already discussed in our previous video. This shows the location where our label will be observed and stuff. So I've changed this based upon various trial and errors, and I found this combination which was giving me a good result. And the next thing which I want to talk about is the tick labels. As you can see here, these tick labels are the values which I want to represent in our color bar, which shows the elevation of the whole cell, whatever it's representing. So once we got that, the overall label I wanted to have for the color bar is elevation, because it's a digital elevation model map. So these are the lines which have changed. So the lines 57, 58, 59 and the lines 29, 30, 31 with 24, 25 are the lines which have changed mostly compared to our previous shapefile plot. So once if we plot this file, the map should show us the results with the TIFF file showing various elevations in different colors. So if we see the plot here, we can see the digital elevation model map. As you can see here, if we make the map bigger, we can see that the blue elevation shows 0 to 20 elevation, etc. with different values. So if you see, there is a little bit issue with the sizes of the color bar, which we can of course change it by going back here. We can tell this to be around 12, and if we run the code again, we can see that the result is quite better. You can see the 0 to 20 is represented in blue, 21 to 167 is represented in yellow, green, orange, brown, maroon, gray, and white. So these are the elevations of this certain area in India, and I've used these following lines of code to make that plot visible. You can change those colors and everything based upon your preference and make it even better. So this is one way where we can do it for digital elevation model. So if you want a similar plot with different things like flood depths, let's say, let me just show you how easily we can do. I'm just commenting everything because I'll be using the another code here. So if we run the same code where I just have another file which shows the flood depths at a certain in Catalonia. So this is the data again which is freely available, and I will give you the website where you can download the flood depths for whole Spain or Catalonia or any zone. So if we see that plot here, we see that everything is changed because I have imported another code which has different ticks, different labels, the different zpal values. Here I'm showing the same kind of code by just changing few lines. For example, if I show here, I change the values of zpal, pal RGB, and then that of ticks. So using those files and also changing the tick file for sure, we get this flood maps showing various depth at various rivers in Catalonia. So this is how easily you can do these plots. Like for a second we had this plot which showed various locations of Krishna river basin in India and its digital elevation model, and in the next plot using the same kind of code by simple tweaking of parameters we have a flood map. So in this way you can use this code for developing a flood map so easily in Python. So that is it for this video. So if you have understood this concept, please give this video a like, subscribe to the channel, and share it with people whom you think this would be useful.